We're going to cover a couple of presentations on incident tracking, which is more real-time kind of security issues. And lastly, we'll have a look at a couple of disaster recovery type of presentations. Along the way, if you have any questions, please don't hesitate to ask them in the questions panel on your GoToWebinar. We've also got with us Robin Rennie, who's going to be trying to answer questions as we go, and Natalie and I will also try and keep our eye on the questions, and we'll answer them as they pop up if we can, or if we see them, or if we know the answer, I guess.
Yes. So first we're going to look at some data management and data resilience type scenarios. So data is key to emergency services and disaster recovery. In an emergency, you need to be able to have access to your key data sets. We've got a couple of examples of how FME users have solved some of these complex data management issues.
Okay, so I'm going to kick off a series of examples with one from the Indiana DHS and the Indiana map. The project implementation started in about 2007, kind of wrapped up in 2012, but so that was the project implementation, but the Indiana map is still up and running, of course. So this project's an example of data harmonization and aggregation, which is going to be a very common theme throughout this whole series of presentations, I think you're going to find. So the project was about bringing county data into a single data warehouse that could be served up on the Indiana map. It was a collaboration of effort between the Indiana DHS, the Geographic Information Office at Indiana, Esri Services, Safe Software, and of course many of the data providers who are the Indiana counties. The requirement was to share basic GIS data across the state. As the saying goes, the whole is more than the sum of the parts. The data requested from the 92 counties in Indiana is mostly cadastral and road data, point addresses, parcel shapes, geo-administrative boundaries, street center lines with the address ranges, and so on. So the big problem is, how do you get 92 counties to buy into a data corporation project? I think that must be a bit like herding cats. That's a bit of a difficult task, especially when everybody's a little short of money, as they were at that time when this project started in 2007. So to start with, the best way to get people to buy into a project like this is to use the least intrusive approach you can to sharing the data at the county end of the data pipe. So this was done by getting the counties to set up an OGC WFS stream based on their data. They did have a little financial incentive to do that. I think there was funding of about $15,000 for those people that bought in early into the project to set up their WFS feeds. Using WFS means that the minimal changes are required at the data supplier's end of the pipeline in their data systems and infrastructure. The data can be pulled, and there's no scheduling tools that need to be pushed to be added to that infrastructure. The other key incentive here was that the WFS stream was in the county's data model. So again, no software needed to be added at the county end to rejig the county data model to the data model that was used in the Indiana DHS data warehouse. FME server was used to pull the WFS data and then convert that county model into a common data model of the Indiana DHS warehouse. So the three key routes to success in this project was, first, the non-invasive approach to serving the county data through WFS. The second was configuring FME's Safe Software's FME server to pull the data on the WFS feed, and at the same time convert those data models. Potentially each county could have a different data model for its GIS data. So FME was used to convert that data model into the common Indiana DHS model. And thirdly, make the resulting common and harmonized data easily available through the Indiana map. And actually, we've got a link there, Natalie. Maybe we could go have a look at the Indiana map. Sometimes it's a little slow to come up, yeah, and we could go to the data and resources, and I think it's the Indiana map gallery, yeah. And so there you see the layer gallery of some of that data. That's the whole Indiana map. I think the data that this serves up is probably not shown here, of course, but it's the streets and other resources. So that's on the Indiana map there. So the outcome of this project was a statewide coverage of data. Again, the sum is better than the parts. Any potential businesses coming to Indiana have a common data view so they can do better site selection. So that was one of the goals of this project. Indiana DHS has a statewide coverage of data so that any natural disasters or other security issues can be easily monitored. And of course, each county can easily get back a data set of their neighboring counties if they need that. So that's really great. And just one thing is that the technology to set this up is not really that complex. It's relatively straightforward. The hard part of a project like this is really political, how to get everyone to cooperate so that so those simple incentives, the non-invasive nature of the project really helped there. So that's it from Indiana. What have we got up next?
So there's another data management story, and it's from Lou Manglas, who was with the Athens-Clarke County Police Department. And Mark is going to explain how the County of Athens-Clarke used FME Cloud to address some data management issues.
Yeah, so the theme here from Lou was what do you do if you lost your data center in a flood or other nasty incident? So, and how do you set up a data recovery program at minimal cost to protect your data? So this is particularly a problem for small organizations. You know, if you're a relatively small county in population and geographic extent, and if you've got a relatively limited budget, which was the case here. So the solution from Lou was to shove his data up in the cloud. Athens County pushes their data into their Amazon Cloud RDS, which is a PostGIS database. You only have to pay for the storage, which is relatively inexpensive when you're just loading the data up. FME's role in this project is used to pull data from a variety of county data sources and push it up to the cloud databases. So the data is secure and somewhat independent of the location of the operations center, which is also important, especially if you've got a small geographic area. A disaster might cover a wide part of that area. So the source data for this kind of data collaboration comes from multiple departments and agencies in the county, planning, the assessor, fire, police department, traffic engineering, and any state and federal data that might be available. So once again, another data harmonization project. So in the event of a disaster and the loss of the operations center, you can fire up additional cloud services very quickly. You can lay a simple web interface on that data if you need to. In their case, any data analysts who need to access and modify the data during a disaster can get to the data through Esri ArcGIS. They also have GeoMedia, or did have. They've also got, he mentioned they used QGIS in some cases. Consumers of the data can view the data through web maps served up through ArcGIS Server. They also had boundless OpenGeo and some simple custom web apps. So really easy to fire up an interface to that cloud data set. So you have a simple but relatively robust and easy to manage data recovery system, and it's cheap as well. So that's obviously a really good incentive, this. And also, again, this is a non-invasive path. So really all we need to do is to push the data up into the cloud. You don't really have to make many changes to your current operational systems. And so again, that lowers the cost of entry into a project like this. Okay, so next sort of section we're going to cover is around public safety. We've got a few ranges of topics here, and these range from data analytics through to the presentation of data to the public to make them aware of possible public safety issues. We've got 5 short examples around public safety. And I'm going to kick this off with a presentation that was given by Nut Jetland from the Norwegian Public Roads Administration. So we got a couple actually on road safety and monitoring, I think, here, isn't that right? Yeah. So the problem here was in rural areas higher up in Norway, I guess this would apply to Canada because we've got moose, don't we? So how do they reduce the traffic collisions with moose who are wandering around on their rural roads? So that's, I guess that must be a real problem that they encounter there. So in this example, Knut of the Norwegian Public Roads Administration showed how they used FME's transformation tools to analyze accidents caused by moose collisions on the highways, and then start to look at how the high road conditions could be improved. The MPRA used FME to consolidate 4 primary characteristics of the roads: the road geometry, obviously, street lighting, and maybe it feels like lightning struck when you hit a moose. So street lighting, traffic volume, and obviously the accident locations. And so this can generate a picture of the road hazards. What they were doing here was using some of the LRS, which is the linear referencing systems tools in FME, which can help define high accident zones. You can compare those zones to the other road characteristics and determine areas of improvement. So these workflows are relatively complex in FME, so we're not going to dive into that too much. But you can use the link on this presentation to have a look at the full presentation from that Knut put together. So using LRS methodology, it's easier to find common segments of high accident density where there are no street lights and so on. And so just in summary here, using data from wildlife accidents and information about street lighting and traffic counts, they were able to identify areas where moose accidents were most likely to occur, and where additional signage or additional street lighting could improve traffic safety. And on the map there, you can just see on the right side there, where we've got the orange and green together, is kind of an area where there's no street lighting and where there are high accident zones, and so that's probably an area where they would focus their road improvement on. All right, so up next is another road safety issue. Natalie's going to give us a quick overview of some traffic safety that the city of Edmonton pulled together for us. Edmonton's in Alberta, is that right?
That's right. Yeah, so we're going to Canada now. So in a way, this is another data aggregation problem. The city of Edmonton's Office of Traffic Safety has a lot of traffic safety data, but it's in different data silos. As demonstrated in the cartoon image, it's difficult for one source to be aware of another. There's a lack of communication, and it's hard for different data to be aggregated, as there are a number of different owners and the data is in different formats. Some examples of the data includes collision locations, red light violations, city neighborhoods, police divisions, and traffic surveys. The OTS wanted to reduce the prevalence of fatal, injury, and property damage collisions through the 4 E's of traffic safety. Do you know what the 4 E's are, Mark?
No, I don't, Natalie.
So they are engineering, education, enforcement, and evaluation. 3 broad steps allowed the OTS to integrate data. First, FME Desktop was used to create base layers, an intersection base layer and a mid-block base layer, consisting of a road network. FME is used to clean up and simplify the road network into a straightforward segment node model. Actually, quite a bit of work is done in this step to prepare the road network. Step 2 involves cleaning and formatting the data sets. Then they can be merged together. In this case, the biggest problem was the collision data, which was not georeferenced. FME was used to geocode 37,000 collision points, which sounds like quite a lot to me. Using FME to geocode the points is a huge time saver, as manually it takes 5 minutes to enter one point. So if you do the math, that adds up to quite a lot of manual labor. Once the base layers and spatial data sets have been achieved, it's time for spatial linking. With FME, linking the data spatially is possible by using some of the spatial join relationship tools. With spatially linked data, it's possible for the different data sets to be linked based on layer ID without requiring the base layer. With integrated data, the Edmonton Office of Traffic Safety was able to create a dashboard that shows the accident statistics at a specific intersection or segment and run an analysis on the site. A great quote from Brandt of the Office of Traffic Safety, which summarizes the importance of this data aggregation solution is, quote, "When all data sets are linked and accessible, we can turn the data into information and the information into knowledge," end quote. As well, the OTS can work towards its vision of zero traffic-related injuries and fatalities in Europe, Edmonton, sorry, not in Europe, in Edmonton only.
That's great. We've got one good question here from our last segment on data security, actually. Somebody asked, what if you put the data up in the cloud, could you lose it up there? I guess, could it float away, get blown away? So, yep, I think the answer to that is, yeah, talk to the people that are hosting that cloud data set, but our cloud expert here, he calls it the 11 nines or something, 99.999% reliability. So those databases can be automatically backed up and replicated. I think those systems automatically do that for you in some of those cloud systems. So I think once your data is in the cloud, it is pretty secure from that point of view. Of course, there are other security issues that need to be addressed around letting other people get access to that database. But if you have a private virtual network, then that shouldn't be an issue either. So that's a good question. Keep the questions coming in. Okay, up next, Natalie's going to give us another traffic safety example. Oh no, it's not. We're moving on. Sorry, got lost here. We've got something from the local RCMP E-Division here that are strong users of FME. And Natalie's going to talk about some of the work they did on publishing crime statistics.
Okay, so the city of Nanaimo, which is a city on Vancouver Island, they wanted to publicly display data, property crime data, through an online mapping application. But as crime data has much information which is not appropriate to be shared with the public audience, they had to do some transformations beforehand. With the help of the RCMP, which is the police here, the city set up a procedure to anonymize property crime incidents by removing personal information and generalizing marker locations so that it could be publicly shared. FME Desktop is used to process the property crime data from Excel files. First, the addresses are anonymized and a generalized crime location point is generated. This involves changing the crime location point from the exact address to the street center point. The workflow has to handle differences in naming conventions, so street names can vary, or the street prefixes, whether it's a street or avenue, intersections and apartment numbers, so they not including the apartment number field in the data, and so on. After anonymizing the crime address, non-confidential crime data, such as crime type and reported date and time, is attached to the crime location point. In this situation, FME manipulates the crime date and time so that they are well represented in the output. As a result, a property crime map is hosted by the City of Nanaimo, which publicly provides recent and historical property crime information. So let's take a look at that map. And on the map, if you zoom in, you can see that different icons represent different types of crime. For instance, there's a theft of a bicycle under $5,000.
Oh, that hurts.
Or shoplifting, so there's a little cash register for the shoplifting crime. So you can view different data in the balloon, such as the reported date and time, the file number, as well as the generalized location. It's also possible to add some filters to the map. So for instance, if you're only interested in a particular type of crime or a certain area of the city. You can also download the data in, say, CSV, JSON, or KML format, so you could perform additional analyses on the data. So we head back here. And so overall, this was a successful application of FME.
Yeah, so keeping the public informed, so that's always comforting, I guess. So next up, Natalie's got a customer story presented at last year's FME 2014 user conference from California CAD around reverse 911.
Yeah, so I wonder how many of you only have a cell phone and no landline phone. My guess is that the number is constantly growing. I, for one, only have a cell phone. And with an ever-increasing number of people ditching landlines for cell phones, the methodology for reverse 911 needs to be reviewed and updated. Mark, what do you know about reverse 911?
Reverse 911 is trying to find your location from something. I don't know where.
Yeah, well, it's a combination of addresses, telephone numbers, and GIS to notify the public about emergency alerts, which could include evacuation, wildfires, and boil water advisories. So it's sort of like instead of you calling emergency services, they call you with a message about.
So community outreach
Yes,
around incidents.
That's right.
Cool.
So using traditional methods of geocoding, approximately 35% of cell phone numbers were not usable for reverse 911 notifications in a U.S. municipality. The city wanted to improve the match rate of notifying mobile numbers during targeted emergency broadcasts and also wanted to enable the county emergency dispatch system, the reverse 911 system, to interface with the municipal city GIS. FME Desktop was used to improve the match rate. The first FME workspace processes data from 2 mobile phone companies. One company submits data to the city once a month, the other company every week. So this was one of the challenges that needed to be addressed. And then the mobile phone company data is inserted, updated, or deleted from the database. Once in the database, the mobile phone data is combined into one data store. This process involves data normalization. Finally, 7 data sources are used in a geocoding process. Scripted batch files are used to automate the workflow. As a result, the city is able to display themed data in a map and performed analyses such as buffering, create and pull reports, and notify residents. FME saved the day as nearly 100% of the records were matched with the new methodology.
Thanks, Natalie. I just wanted to mention as we go, this is a bird's eye view of quite a few customer stories, and everybody will receive a follow-up email with this set of presentation slides as a link. And on all of these slides, we've added the link. You can see it here. This one's to an FME blog that you'll be able to go to. So if any of these ideas kind of interest you a little bit more, you'll be able to track down the original presentation, and if there are any FME materials with those presentations, you'll be able to grab those. So next up, well, Natalie's on a roll, so we can't stop her, but she's switching to a very different public safety issue, tracking World War II ordnance on the Solomon Islands.
So in World War II, much ordnance such as grenades, bombs, and mortars was scattered throughout the Solomon Islands, and the New Zealand Defence Force, along with other defence forces and local authorities, were tasked with Operation Pukarua in 2013. The operation aimed to find and safely clear unexploded ordnance in a variety of states littered throughout the island's water, jungle, and inhabitants' gardens. With the assistance of local people, the ordnance was located, as they were often obscured. Once located, data regarding them was loaded into a dynamic enterprise database, SDE, with Esri technology. The operation wanted to distribute the data back to stakeholders in a method which would not require a professional GIS, as well as link a variable number of images to each ordnance point and retain GIS attributes. It was decided that Google Earth and KML would be well suited for this. Using FME Desktop, it was possible to obtain image names such as attributes, create KML features, and attach a variable number of images and other attributes to the KML features. So the images and some of the information attached to the images are displayed. So these would be balloons in Google Earth. By using Google Earth and KML, it was possible to distribute the results back to stakeholders in multiple countries in a well-known and simple interface, which does not require a professional GIS system. In conclusion, the project was able to successfully remove over 2,000 ordnance items.
That's kind of a legacy cleanup thing. That's a big problem, I guess. Really big problem.
Yeah.
So next up, we're going to start to look at a couple of incident tracking kind of problems that we have dug up from our users. These are events that need to be monitored in more real time. So this could be anything from tracking assets to having the right data available to allow you to respond to real-time events. We've got a couple of examples here where Safe Software's FME products have been used in this arena.
So this first incident tracking example we'll look at is from the LA airport. It was first presented by Betty Dong and Michael Sabatino at the FME World Tour 2015 event in Los Angeles.
Yeah, so this was a really interesting kind of project, and really it's another, you guessed it, data harmonization and aggregation story. So the goal of the Airport GIS team was to make a comprehensive data set of the airport available on mobile platforms, namely iPads. So this consolidated data could then be used as a backdrop for users to be able to submit and respond to incidents on the airport field, as it were. So within the airport buildings and out there on the airport pavement, I guess. So FME Desktop has been used to read data from many distinct systems, each with different owners, so that's sometimes a little bit of a political issue in an organization, and join that data together into one uniform format. So breaking down the stovepipes of data management, I guess. The end format has been an Esri geodatabase data set. I think that's then probably just distributed on a file geodatabase that Esri mobile products can use. So the data sources included engineering data, both CAD maps and data coming out of Oracle Spatial, environmental and noise data, a lease database they have, which is called PropWorks, data coming out of Maximo, which is a work order system, and they also have a tool for incident management called the NICE Situator. Automation of this process is accomplished with FME Server, so on a regular basis the data is pulled out and loaded up into the latest copy of the geodatabase that the mobile users can grab and go out in the field with. So again, the airport field staff can efficiently report and respond on incidents that they have encountered, and they have a complete up-to-date view of all the appropriate airport data in one common database. Also, other users at the airport outside of the immediate target audience, who are those mobile users, can have a data set that's automatically kept up to date and has a more cohesive view of all the data that's the appropriate data in the airport. So kind of they're heading to potential target audiences with that process. So another data harmonization issue, so that seems to be a really common theme throughout everything we're talking about here.
So yeah, next in this incident tracking theme, Mark is going to present a FME customer story from the Iowa Department of Transportation regarding snowplows.
Yeah, so this is an example of another example of keeping the public informed. In this case, to give the Iowa public a clear picture of the Iowa DOT snowplowing efforts and help them make safe travel decisions based on up-to-date information. Well, it might be hard to picture that in the heat that we're having here in Vancouver anyway, but in the wintertime that's pretty critical over there. The other goal of this project was to improve the efficiency of their snowplow operations and see if they could save some money at that end. So the Iowa Department of Transportation wants to maintain their winter roads efficiently and provide near real-time situational awareness of the road status. So in this case, FME is used to stream real-time data from the snowplows, that's the locations and images from dash-mounted phones, into an Oracle spatial database. FME is also used to move that data from the Oracle database into a more public-facing portal hosted by the Esri ArcGIS Online. The Iowa DOT is also able to analyze the road conditions from the data that's been stored in the Oracle database to ensure that the winter roads are maintained in a most cost-effective manner. So they can sort of do post-processing of the data to see how they can improve their operations. The public data access increases winter driving safety as people can check the real-time conditions before heading out on the roads. And also what they found is that the local media and weather outlets can disseminate the data because they have these real-time images from the snowplow that they can get to. And I think if you click on that image there, it's got a link to the data set. Now they don't serve up this data in the middle of the summer, so we can't see that. But this is the Iowa DOT map base, and I think in the wintertime on the featured apps, you'd probably see the winter driving conditions come up there when the snow starts. Also, there is a good return on investment which can be significant. Making the plowing of the roads more efficient reduces the amount of salt and brine. 10% on reduction in salt and brine laying out could result in up to, well, more than $1 million in savings for a snow season. So that could be significant. So anything they can do to improve the efficiency of this process is good. Of course, what Eric Abrahams and his team at the Iowa DOT has done here could be applied to any mobile assets you might have. So this is just a good example of using FME to monitor mobile assets and do something interesting with that data. But I got to say, I think one of the key innovations here was the use of cheap dash-mounted phones for the locations and the image capture. That was really pretty innovative. It's easy to replace the phones if they get broken in that harsh environment, so that's good. I've got to say, I think also innovative would be using FME to do the heavy lifting behind the scenes, but maybe we shouldn't be promoting that too much.
So after an event, now we're going to look at some disaster recovery scenarios. What data can help you after a disaster event? Well, we've already seen that consolidating data is a good way to secure your data. How do you use this data after an event has happened, or perhaps to predict the consequences of an event? The first we're going to look at is a dynamic flood calculations. It was first presented at the 2014 FME User Conference by Henrik Thoren of Ramboll, which is located in Denmark.
Yeah, so Ramboll was tasked by a customer to build a hydraulic model of one of their customers to predict flood behavior. I guess this is a bit more of a predictive analysis story rather than disaster recovery, but we can keep going with that. So the dynamic flood calculations required a variety of scenarios such as climate adaptation and storm water management, so that's what the analysis covered. So Henrik uses a range of hydraulic modeling tools for potable water, sewer, or as the Irish call it, foul water, which is kind of interesting, foul water systems, river system modeling, and also overland or terrain flow modeling. These applications that he's using, they can be coupled together to actually generate an entire flood response modeling. In the presentation that Henrik gave, he showed how he's using FME to build a modified DTM, a digital terrain model, for the area of interest that he wants to do the flood modeling. This includes the locations of buildings and other structures that are going to affect the flow of water during a flood. So he used FME to take a standard digital elevation model and then add in the buildings from shape files of the building footprints. So at the top series of the images there, you can see that kind of process. He's got the DTM, overlays the building footprints, and then adds those building footprints as a kind of an elevation into the model so that he can show where the water's going to flow around. So that DTM model is then used as one of the many inputs that he's got into his flood models. Henrik then uses his flood modeling tools to model the various flood scenarios that he wants to put together. In his second use of FME, he's taking the output of the flood models into FME, and those are coming out as grids or rasters, and then calculate different characteristics of the flood results, such as the area of the flooding, volume of water involved, and also various statistics from the results of the flooding model. His outputs from this are Esri shapefiles for viewing in ArcGIS. I don't know why he's using old shapefiles. He could go to Geodatabase if he wanted. And he's also using MS Excel. He's sending the data out into Excel for reporting. In the Excel results, he can show his customer the summary of various modeling scenarios, so they can picture how adding a pump station can change the results of the flooding or the potential flooding that's going to happen. So in summary, Henrik here is using FME as a wrapper around his main flood modeling applications. First, to pre-process some of the data, which is the DTM, as an input into the flood model, and then second, to post-process some of the flood model results and summarize them in ArcMap for Excel so others can get easy access to the results of his hard work.
Sounds good.
Yeah. And so we're going to wrap up the series of presentations with Natalie's going to do that with a truly remarkable disaster recovery story about the rebuilding of Christchurch, New Zealand after the 2010 and 2011 series of earthquakes that they had to suffer through.
Yeah, so this is a pretty real disaster recovery story. Christchurch, the second biggest city in New Zealand with around 400,000 residents, was hit by 4 large earthquakes between 2010 and 2011. They ranged in magnitude from 6.0 to 7.1, and more importantly, they varied in peak ground acceleration from 1 to about 2.1. As a result of the earthquakes, much land was liquefied, over 6,000 homes were destroyed beyond repair, nearly 80% of business buildings needed to be demolished, and underground utilities, roads, and transport networks were all severely damaged. The Stronger Christchurch Infrastructure Rebuild Team, or SCIRT for short, is tasked with fixing the horizontal infrastructure and helping to return Christchurch to pre-earthquake conditions. SCIRT uses FME in many ways. First, let's look at its applications of FME Desktop. SCIRT consumes data from over 20 organizations in a variety of formats. FME Desktop converts all sorts of spatial and non-spatial data into the SCIRT projection and formats. Another workflow involves the Esri ArcGIS Flex Viewer. So the Esri ArcGIS Flex Viewer is used by a variety of users with varying levels of data access. The config files, which are XML files, for the multiple roles used by the Flex Viewer are created by FME. Thirdly, FME converts local council data in 2D into 3D as SCIRT designs everything in 3 dimensions. GPS photos are also handled by FME. After GPS cameras take photos, with FME, the photos are manipulated by adding watermarks, resizing them, and extracting and adding additional information, as well as creating Esri geodatabase features. Finally, the photos are added to a GIS viewer. As the last FME desktop example, SCIRT uses FME desktop for pseudo-regression analysis to determine which pipes are likely to be damaged without requiring CCTV of all pipes. Originally, the process took one person, 1 week in Excel to perform. With the switch to FME, it now only takes 3 hours, which is a huge time saver, and the process doesn't require one specific person to run it. This analysis saves about $64 million. FME Server is also used by SCIRT. As one example, a directory watcher watches for Excel file additions which will be uploaded to Microsoft SQL Server. The workspace is also used to remove empty rows in Excel and unzip files. FME Server in the future will be used to check construction as-built data coming in. To summarize the results of SCIRT using FME for the rebuild of a city, it saves time, it's able to output data in the formats and dimensions required, it's easier to create the different roles for the ArcGIS Flex Viewer, and it's possible to display images with additional information in a GIS viewer.
Yeah, that's a really remarkable project, a wide range of uses of FME, but again, that common theme, the data harmonization and aggregation seems to be the theme for using FME, and most of these examples that we've put together, that seems to be a problem in all of the emergency management. We have data in silos, which is fine on a day-to-day basis, but when you really need to access that data quickly, it needs to be in some sort of common place that's easy to get to so that you can work with it. Well, so that's it. A very high-level bird's-eye view of 11 of our customers that have been accomplished, to see what our customers have been accomplishing with FME products in the emergency management and services kind of arena. Hopefully you found these enlightening talks informative. As I mentioned, you will get a follow-up email that will give you a link to this presentation, and then on all of those customers' presentations, we've given a link back to the original customer presentations, and in the notes there are other links as well, so those PowerPoints will be pushed up with the notes, our speaking notes actually, I guess, but also we'll have links, additional links to some of the other presentations related to what we've been talking about here. We've got a few minutes for questions, and one person did throw up a really interesting question, which is probably outside of our realm of expertise, but I'm going to throw it out there because I think it's a really good thought. So he's asking, how do I evaluate my data management if I'm an emergency manager, and how do I compare to alternative data management practices? So that's a really good question. I'm sure there are people more qualified than us to answer that, but I think you can see from the different, particularly the first two presentations that we gave there on the Indiana map and Athens County, you could see very diverse approaches to that emergency management scenario. How to evaluate which one is more effective than the other depends how you evaluate it, whether it's on cost or reliability or whatever, but that's a good question. Thanks for that.
Okay, so coming up, there's a number of FME training courses. All these online courses are free and instructor-led. The FME desktop and server training courses include a remote desktop connection, an Amazon Web Services machine, so you can do the exercises during the training. So there's one at the end of July for the desktop basic, as well as mid-August.
I think that July, the one at the end of this week, actually that's the end of this week, isn't it? That's aimed indeed, more yes, for our European and East Coast users, so it's a bit an easier time zone for those people. So that's a good one if you're from overseas.
Or if you're an early riser on the North America, you could take part in those ones too. And then at the end of August, there's a FME Desktop for Esri training course. This is more of an instructor-guided workshop. There's not a remote desktop machine provided, but you can download the materials and use your own copy of ArcGIS to try to follow along while the instructor works through the workspaces.
Okay, so that's a wrap from us. Thanks very much for attending and giving us 50 minutes of your day. Very rarely for a webinar at Safe Software, we're ending ahead of time slightly, so you actually get 8 minutes of your day. So with that, it's goodbye for me, and
goodbye for me. Happy FME adventures.
And good luck with your Windows 10 downloads, I guess. All right, thanks very much, everybody.